We're going to do a quick presentation on digitally steerable arrays for the production market, and in particular we're talking about corporate AV production market. My name's David Ron. I'm the National Sales Manager for Renkus-Heinz. We're a US-based manufacturer of loudspeaker systems based in Southern California. We've been around for about, is it 30 years now? 32? Oh my God. Just a couple years less than me. So, IC Live is a product that we introduced a little over a year ago. It was introduced based upon some feedback we had received from sound designers and corporate AV houses that were doing productions that required some slightly different technology deployments for their applications. They were looking at systems that were a little less obtrusive visually. They were looking at systems that were going to provide more even coverage. They were looking for upsides such as smaller truck pack, more convenient deployment, ground support deployment, and they had seen some of the benefits of our digitally steerable array in the ICR series, liked what it offered, liked how it was able to overcome some of the challenges that they were addressing, but its deployment, its form factor really was not set up for that portable marketplace. So we designed the IC Live system to meet those specific needs. And we also make this available for the installation market, of course, but again, this was really driven by some feedback we had received from some friends in the corporate AV production market. We have a full system over here on my right-hand side, consisting of two of our double 15 subwoofers and two full range units. What you see here is a variety of different deployments of the various building blocks, if you will, in the IC Live family. The full system is the double sub with the double tops. We've just recently added an additional module, and the software has been updated to allow the sound companies to deploy 3 tall arrays as well. So we're able to address some really large spaces, overcome some really significant challenges, present a whole bunch of different upside from a technology standpoint to the user in this application. What is IC Live? Well, IC Live, its full range module comprises of 5 6.5-inch neodymium woofers, 3 1-inch compression drivers. This is a fully self-powered system. It is modular and expandable. It's a very slender enclosure, very low profile, easy to deploy hardware, and it is as well Rayon controlled. And we're going to talk a little bit about what Rayon is. Rayon stands for the Renkus-Heinz Audio Operations Network, and this is a control and audio distribution network element for all of our self-powered speakers. The subwoofer for the IC Live system is called an IC215SR. This is a dual 15-inch bandpass subwoofer. It comprises a 2-channel, 1,000-watt per channel amplification system, and again is as well Rayon controlled. It also has integral hardware for both the ground and flown deployment applications. Let's talk specifically about some of the features of the IC Live system and some of the benefits that come along with that. First of all, the slender design, it easily blends into most of those corporate AV environments. Most of these types of shows, you got a big stage, you've got a big backdrop, you're using large-scale video screen reinforcement. There's talking heads, there's camera angles to consider, video projection systems. So you really need something that's not going to be obtrusive, but you also need something that's going to cover the space adequately. So its slender form factor works really well in these spaces. You've got minimal sightline impacts. Again, the intensive video environments, it really overcomes those challenges. It's very fast and easy to set up. I've done a few shows with some of our integrators, and one of the things that they notice right out of the gate is how easy this system is to deploy. If you take a look at the system over here, the full range units, the double subs, we set up a system, a left-right system comprising of this system here within about 20 minutes. Had it wired up, audio delivered to it, all ready to go within 20-30 minutes. So what does that mean to the user? Well, it reduces your load in and load out times, and that's just basically a savings to you from a job costing standpoint. Additionally, this is a very high output system. You can do a whole bunch of different things with it, and this is really the first high output digitally steerable array available on the market and designed specifically for these applications. So you can now start considering doing things like the first 2 or 3 days of these corporate environments generally consists of, the keynote speech, consists of a sales guy like myself up there talking about the numbers and last year's performance and what we're going to do this year, maybe some PowerPoint, some multimedia presentation, and then at the end of it all, well, they open up a bar and they bring on a band. The IC Live can handle all of those applications. So it has the output capabilities to handle full live music and all the dynamic content you might come across in these environments. To continue with the features and benefits, what is digitally steerable array? Well, I throw about the phrase interference-based line array, and what it really comes down to is that in these full-range devices, again, we talked about the components in there. You've got 5 6.5-inch woofers. Each one of those woofers has its own amplifier channel. So this is an 8-channel module. Each one of the compression drivers as well has its own amplifier channel. Each one of those devices as well has its own DSP engine. We deploy special filters called FIR filters, and because of this unique deployment of technology, we're able to manipulate phase and magnitude independently, and that ultimately allows us to create these very narrow vertical acoustic beams. So instead of a line array where you've got your woofers summing together and you've got horns that are plane wave generators where they don't interfere and they just try and project in a real straight long throw application, these systems combine by interfering with one another in a very proactive way to create very narrow vertical beams that you can then in turn progressively delay with electronics to steer the audio down to the listening plane. So the overall benefit of that is that you're not energizing the ceiling, you're keeping the audio in its intended listening area, your intelligibility is significantly improved, you've got really good fidelity and coherence as a result of all of these technologies being deployed. One of the real serious upsides to this type of system is its increased throw capabilities, and I'm going to show you a case study in a few minutes of a job that was done this past year where we deployed this system in a very large space. When I talk about increased throw capabilities, a system like this can easily be deployed in a ballroom up to 200 feet and still get great level all the way to the back room. You can even use these outdoors and achieve the same kinds of results. Obviously, the interference-based technology, the steerable capabilities provide increased intelligibility, and obviously in these corporate AV environments, that's what's most important. The people need to understand what the presenter's talking about. One of the additional upsides is that you really do overcome the need for these delay speakers. In a lot of these spaces, you go into these ballrooms, you're going to fly a small PA of something like the CFX 101s or like a JBL VRX series or any of these small mid-sized line arrays for your main left-right. And then 50 or 60 feet out, you're going to put another couple of speakers. Another 50 or 60 feet out, you're going to put another couple of speakers. With a digitally steerable array, you don't need to do that. And again, that reduces your overall installation time, the labor associated with it, and significantly reduces your job costs because you're not flying systems anymore. All of this is ground stack deployment capable. Rayon onboard DSP with preset functionality. This is another really nice feature that lends itself well to these applications. When you look at the back of this system, you'll see a little LCD display or an LED display, two-segment LED display, and you can basically program different beam structures and coverage characteristics into this system, store it for immediate recall. So you can go into a situation where you're in a ballroom and you're going to be covering an 80-foot long throw, program a beam structure to cover that, program some EQ for the specific application. Maybe day 2 they're going to open the moving wall. It's now going to be a 160-foot space. You program that in ahead of time. You can push a button and recall it, and it changes its configuration to now cover that additional space. So a great deal of flexibility there with the preset functionality. And as well, Rayon itself has a great deal of other features as well, and I'm going to talk a little bit about that and just give you a quick insight into Rayon software. Very quick, easy, and easy to use software package. So the case study we're going to talk about was this past year's Super Bowl halftime show press conference. We were working with a rental house that we've done some stuff with, the AVW Telav guys. Obviously a big outfit. They have offices all around the United States and throughout Canada. The venue that we were working with was a very large ballroom, and it was about 220 feet wide, 145 foot deep, typical ceiling height of about 25 feet. They set it up for a seating capacity of about 1,200 people. The stage was extremely wide. It was about a 55 foot wide stage, about 15, 17 feet deep. It had a big LED wall behind it. On one side of the stage, we had a big HD LCD screen. we had to mount the speakers left and right of that. This is actually a picture from the previous year where we did the first deployment of IC Live. So you don't see the LED wall here, but this gives you an idea of the scale and the way that these things can be deployed in these spaces. Oh, let's go back. What I'm going to do now is actually show you in Rayon how we would program this system. It's very simple. And some of the capabilities of IC Live. It gives you a great graphic representation of the system and its throw capabilities and the way that it manages the acoustic energy in a space. So I've opened up Rayon. I've basically added a virtual device of an IC Live Dual, which is basically this system right here. I'm going to double click on the unit, open it up, and what you're going to see is a few different tabs here. The Connect tab is where you would define your input structure. You've got 2 different analog inputs, you've got CobraNet inputs, and you've also got AES EBU inputs, so a variety of different audio formats that you can work with. You've got some other things here like Wink with LED, so when you're setting up the system you push the button and a blue light comes on the speaker so you know exactly which one you're working with. These are all TCP IP devices. This is a very straightforward network topology, so you'd be using Cat5 from a computer to a switch and breaking it out to all the speakers on the network. You can also test the system with a quick sine tone or pink noise. You've got an input meter that you can manipulate, invert, mute. You've got temperature indication of the amplifier. Down here is all of your CobraNet routing assignments if you're using CobraNet. You've got a 10 dB pad as well on the analog input number 1. This little box is actually a signal present indicator, so if there was audio on analog 1 you'd see a green box there. You've also got an interesting function here called priority. This is a priority override. This is designed more for the install market, but we're seeing situations where it might be necessary to utilize it in a portable situation as well. What this basically does is if you have your analog 2 set as a priority override, what might happen is the fire marshal might come in and say, here's a evac announcement feed. If our fire alarm goes off, this signal is going to tell people to leave the venue. It's going to come through your PA, so you could plug it in to analog 2. If signal arrives there, it's going to duck the primary signal and let that evac announcement ride through. The second tab is the control tab. This is pretty straightforward. This is DSP, parametric filters, shelf filters, high and low pass filters. So when you go in and you set up the system and you've optimized the coverage with your beam structure, then you can go ahead and measure the system's frequency response and go ahead and do all the EQ that's necessary to flatten out the system to your liking. You've also got an additional compressor here. Obviously this system has its own protection as far as the drivers and the woofers, but we have an added level of compression that can be utilized. I think in most cases people are going to look at this as something that would allow them to set a volume limit. So if you're in a venue where you could not exceed 95 dB, you could probably deploy this compressor to establish that threshold so that your rogue operator couldn't push the volume past what was defined as the limits for the space. You've got up to 340 milliseconds of delay, so if you're doing a big example, G20 summit that was done recently up in Canada, they had some spaces that were up to 600 feet long, big tents for these political venues. You could deploy multiple units and utilize the internal delay to align the system. And now getting to the beams and presets page, this is where you program a system. And I'm not actually connected to a unit, but if I was, I could push refresh table, and in here it would give me a listing of all the beams that I have programmed into the loudspeaker. I could then at that time highlight one of those beams and load that preset in. What we're going to do is do a quick example and show you the kind of level and frequency magnitude response that you can achieve in certain spaces. So this is the page that we utilize to set these systems up. I'm just going to quickly create a seating plane of about 130 feet long. The room that we were in was about 145 feet deep. The speakers were about 20 feet off of the back wall, and the seating plane didn't go all the way to the back, but I'm just going to assume we've got a much bigger space here. We've got the IC Lives were deployed at about 4.5 feet off the ground. What I typically do is we'll establish a focal point for the focus of my primary beam, and it was a seating environment Once the Who started playing through the PA, most of the press was on their feet, but nonetheless, press conference, most of the folks are seated, so we wanted to make sure the coverage was optimized for both seated and standing. And my focal point in this case, we'll make it 140 feet away. I'm also going to make this beam a much tighter beam. These digitally steerable interference-based arrays, you can manipulate the opening angle, create different vertical coverage patterns. So in this long throw application, I'm going to make it a 5-degree beam. Another nice thing you can do is you'll see up here that you've got beam count. You can actually deploy up to 4 beams per individual module, and in a dual up to 8 beams. So you could do things like create a unique beam that throws to a balcony. You can do things like, in this case, what I would probably do is deploy 2 beams. That second beam is going to be more of a front fill beam. So I'm going to aim that one and steer it more aggressively to these guys in the front row. And again, it all really depends on how these systems are deployed, if it's flown, if it's ground stacked, how deep the seating plane is. Then another cool thing that you can do with this front beam is I can now come in and manipulate its relative magnitude. So, you know, in most line arrays you're dealing with manipulation of the inverse square law. Well, this system takes it a step further. We've done systems where we're covering 160 feet and we've got a variation in magnitude of plus or minus 3.5 dB front row to rear row. So I can go in here and knock down that front beam 12 dB. Now look at what we've got here is in the very front we're 4 dB hotter, and all the way at the back we're still close to 102 as far as magnitude over 1 octave at 1K. So some really cool unique things that can be done to address some of the challenges that you typically see in these spaces. I'm not going to go too far, but we'll do a quick mapping on the system just to see what the overall section view energy is going to look like. And you can go in and change things up a little bit. Maybe I want to tighten things up in the front, make that a 10-degree beam. Maybe I'm going to move it a little bit, and you can see how things change here from a magnitude response standpoint. So an extremely flexible system. Once you've defined the beam structure that you want to use, you can push a button and write it to the device. So it then programs the device to emulate this coverage. You can test it, make sure it's good. If you really like it, then you can go ahead and save it to a preset, or you could just leave it active. If you're not going to be worried about presets, you're just doing one show, just write it to the device. And you can leave your presets for other work. But if you want to do, if you're going to be in this room multiple times, it's a contract that you've got where you're going to be going back over and over, save it to a preset, and every time you go back to that venue, all you got to do is go to the back of the unit, push a button, and recall that system's preset. You won't even need the laptop. You can as well save some of the EQ parameters. So if you go in and you have someone come in with a SysTune rig or a smart live system and they tune the system for you and you EQ it, you can save that to that same preset. So you can do some really cool things with those presets to make it extremely flexible and powerful for some of those applications. Questions? Just about done here, so I'm going to go back to showing a couple of pictures of some different deployments just recently. So in talking about the future of digitally steerable arrays, we've got a handful of companies that have already bought into this and have them in rental inventory. AVW Telav just placed another order, so they'll have 4 offices with full systems now. The next step we're looking at is IC Squared. We brought this along to show to some of our key customers and some of the sound designers we're working with. It's basically another progression forward. Instead of 6.5-inch woofers, we have now 4 8-inch woofers in this system, 4 1-inch compression drivers, a whole new amplification package that allows us to get even louder. This is kind of a hybrid in that we can do certain things where we deploy the system as a traditional line array with respect to the woofers summing together and then just apply progressive delay to tilt the audio. Or we could take a 10-box array and use the top 4 boxes as a tapered array, create a single beam to shoot to a balcony, and then use the entire array as well, tilted, for just the main seating coverage. So a great deal of flexibility exists in that system, and that'll be probably shipping mid-next year. This is Molde Jazz Festival. The system was used in Norway at a big music festival. This is a new customer of ours in the UK, just recently bought a system and is using it for all kinds of corporate events. It's just a quick example of a very simple deployment. This was actually a dealer of mine, did a trade show, brought in all their vendors. We used our system for the PA. We set 2 different presets, one for exhibit mode. We just had background music going and videos running. And then at the end, it was the typical thing. They opened up a bar and they had a little DJ come in, and we set the beam structure to cover the entire tent at that point. Some of its early adopters, again, AVW Telav, M&M Productions out of Tennessee, TM Audio in Belgium, Stage Audio Services was the guy in the UK, RCI in Maryland, Bentley Meeker in New York City. We've got 3 or 4 other folks about ready to take delivery on systems in the US as well. So it's a very unique deployment of technology. It overcomes a lot of the challenges that most systems just can't address right now. You've got the cost issues with flying PA. You know, the union riggers in those hotel rooms, there's a pretty steep fee for going up and going down. You've got the sightline considerations. Just a whole host of things that we're addressing with this technology that you really can't see with some of the other loudspeaker systems. So that's the quick down and dirty presentation on digitally steerable arrays for the production market. I thank you guys for spending a little time with us. If you guys have any other questions, feel free to catch me. I can walk you through the hardware, or I can give you a little more in-depth training on the software as well. Thanks much, you guys.